Hello, fifth graders who are learning from home. Today we did lesson 10, which is subtracting decimals. So on Tuesday, you learned how to add with decimals. And today we're going to be learning how to do a subtraction problem that involves decimals. So to start with, we're going to start with unit form. And we're going to solve the problem 5/10 minus 3/10. We're going to find out what that equals. How many tenths? Now, this is a fairly easy problem to start with, and I bet a lot of you can do it in your head, just thinking about the units. 5/10 minus 3/10. So if I take my place value discs, I start with 5/10, and I'm going to subtract or take away 3/10. So I would take away 1, 2, 3, and I would be left with 2/10. Now you have to be really flexible with your thinking on these problems, and you have to be able to go in between unit form and standard form. So I could rewrite this problem as 5/10 minus 3/10 equals 2/10. And those mean exactly the same thing. The other thing you have to be able to do in these problems is line up your place value. So if I were to write this problem vertically, which I really like the way when I'm subtracting to write things vertically, it really helps me see the place value and how to line it up. I need to line up my ones and my tenths, and that will make my decimals fall in place as well. And if I were going to do it this way, I would say 5/10 minus 3/10 is 2/10. I would bring down my decimal. 0 ones minus 0 ones is 0 ones. Now, for some of you, you may still want to use a place value chart to do this kind of a problem. Your place value chart makes it really simple to go back and forth between unit and standard form. If I were to do this problem, it also makes it really simple to line things up. 0.5, 5/10 minus 3/10 equals 2/10. And then when I look at my place value chart, I can see this in standard form, 2/10. I can also easily see unit form, 2/10. All right, let's try one that's a little harder. What if I had the problem 7 ones, 5 thousandths, minus 2 ones, 3 thousandths. So let's take a look at that one. 7 ones, 5 thousandths, minus 2 ones, 3 thousandths. Now again, I find subtraction problems a lot easier if I do them in standard form. And for this one, this is a great example of one that your place value chart can be a really helpful tool. When I look at this, I see 7 ones. So I'm going to put a 7 in my ones column. I see 5 thousandths. I'm going to put a 5 in my thousandths column. And what goes in my tenths and hundredths column in this number? Exactly, you guys know that, 0. So my unit form is 7 ones, 5 thousandths, and my standard form is 7 and 5 thousandths. And then I'm going to subtract 2 ones, 3 thousandths. Again, what do I fill in these blank spaces? Zeros. Subtracting 2 and 3 thousandths. So your place value chart is a really useful tool helping you go from unit form to standard form back to unit form. Now if I subtract these, I could again use my place value cubes. I have 7 and 5 thousandths. 1, 2, 3, 4, 5, 6, 7. And then I have 5 thousandths. Now again, when we're talking about being flexible with our thinking, I would line up these place value discs like this in groups of 5, and I would do it vertically. So there I can really quickly see that that is 7. And then I have my 5,000ths place value cubes. Now when we're subtracting, we put out our top number, 7 and 5,000ths, and then we take away this number. When we were adding, we added this number to it, so we added more place value discs. This time we're going to take them away. So if I subtract 2 and 3,000ths, I would take away 3,000ths from my 5,000ths, which leaves me with 2,000ths. 0 hundredths, take away 0 hundredths is 0 hundredths. 0 tenths, take away 0 tenths is 0 tenths. And then I have 7 ones, take away 2 ones. And I can see really quickly that this leaves me with a group of 5 ones. So my answer would be 5 and 2,000ths. And I could record that as 5 and 2,000ths, or I could go into unit form and write 5 ones, 2,000ths. Who remembers how I would write this if I wanted to express it only in terms of thousandths? Exactly, this would be 5,002 thousandths. All of these are names, different ways to rename the same exact number. Okay, if you're following along with me, erase your board and we're going to try another problem. This time, instead of using place value discs, we are going to move on and use a chip model to show what's happening with subtraction. So let's put our discs away. Again, I think it's really helpful to use your place value chart. It will help you line up your numbers in the correct place value, and it can also help you with your chip model. So I'm going to move to just using my place value chart. Now, if you don't have a place value chart at home, you can always make one. You guys know how to do it. You just label your columns, thousands, hundreds, tens, ones, put in your decimal, tenths, hundred, thousandths. And this will help you a lot as you do these problems. All right, so the next problem we're going to try is 9 hundredths, 5 hundredths minus 3 hundredths. First step, we change our unit form to standard form. So I see I have 9 hundredths in this number. So I'm going to put a 9 in my hundreds column. I have 5 hundredths. I'm going to put a 5 here. And you guys know, in these blank spaces, I'm going to fill them in with zeros. 9 hundredths, 5 thousandths is written this way. 905 hundredths. Sorry, I meant hundredths. We're going to subtract 3 hundredths. 3 hundredths. I definitely need the 0 here and here. That's how we write 3 hundredths. You could also put a 0 here and here if you want to. Then we're going to subtract. Now this time we're going to use what's called a chip model. So when we use a chip model, we make the chip model for our top number. So I'm going to put 9 in the hundreds place. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to put 5 hundredths. 1, 2, 3, 4, 5. Next, I'm going to check to make sure I can subtract and discover if possibly I'm going to need to unbundle some groups. Here I have 5 take away 3. Can we do that? Yes. 0 take away 0, 0 take away 0, 0 take away, that would be a 0. 9 take away 0. So we don't need to rebundle anything for this number. So 5 take away 3. I take away 3 and I'm left with 2 hundredths. 0 tenths take away 0 tenths is 0 tenths. 0 ones take away 0 ones is 0 ones. 0 tens, take away 0 tens is 0 tens. 9 hundredths, take away 0 hundredths is 0 hundredths. I'm left with 2 hundredths. I'm sorry, I made a mistake. 9 take away 0 is actually 9. I'm left with 9 hundredths, 2 hundredths. And if I wanted to express this in standard form, it's right here. 905 hundredths, take away 3 hundredths is 902 hundredths. Okay, erase your board and let's try another. This time, let's try 83 tenths minus 6 4/10. First thing is to change our unit form into standard form. And you guys should all know 83 tenths is the same thing as 8 3/10 minus 6 4/10. Now you're going to set up in vertical form. You could do this on a plain piece of paper, or you can do it on your place value chart. I have my place value chart right here, so I'm going to write 8 3/10 minus 6 4/10. I'm not sure you can see the columns anymore. I lined up my ones column, my decimals, and my tenths column. Next, I make my chip model. I have 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. I have 3 tenths. 1, 2, 3. Now I check my problem to see if I'm going to do any unbundling. 3 take away 4. Can I do that? No, I can't. 3 tenths take away 4 tenths. I can't do it. I need more tenths. Where can I find some more tenths so that I can do this part of the problem? That's right, I have to take them from the ones column. So I'm going to unbundle 1, 1, and I'm going to exchange it for 10 tenths. 1, 1 is the same thing as 10 tenths. Next step, I need to make my standard algorithm look like my chip model. I don't have 8 ones anymore because I unbundled 1. I now have 7 ones. And I don't have 3 tenths anymore because I added 10 tenths. I have 3 plus 10, which is 13 tenths. Now I can subtract. 13 tenths take away 4 tenths. 1, 2, 3, 4. That will leave me with 3 plus 6, which is 9 tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths are left. I bring down my decimal. 7 ones take away 6 ones. 1, 2, 3, 4, 5, 6. That leaves me with 1, 1. This number, this answer is 1 9 tenths, or I could say this answer is how many tenths? That's right, 19 tenths would be my answer. All right, hope you guys are getting this and it's making sense to you. Let's erase our board and try another example. If you guys don't have your boards yet, now is a great time to pause it. Go get your board and work through these problems with me. It will really help you. And even though you're working at home, I still want you using the chip model right now. I want you to really understand what happens when we unbundle. Okay, for this problem, press play when you're ready. All right, for this problem, we're going to do 9 2 tenths minus 6 ones, 4 tenths. First thing is to put this in standard form. I can use my place value chart to make this really easy. This is 9 ones and 2 tenths. This is 6 ones and 4 tenths. I'm going to subtract. Next, first I write my chip model for 9 and 2 tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9 ones, 2 tenths. Then I'm going to see if I can subtract or if I need to rebundle. 2 take away 4. Is that possible? No, it's not possible. I need more tenths. 2 tenths take away 4 tenths. I can't do that. So where could I get some more tenths from? That's right, from my ones column. I'm going to unbundle one of these ones and change it into 10 tenths. So on your chip model, cross out 1, exchange it for 10 tenths. Then make your standard algorithm match your chip model. I had 9 ones, but now I have 8 ones. I had 2 tenths, but now I added 10 tenths. 10 plus 2 is 12. Now I'm ready to subtract. 12 take away 4. Cross out 4 of the tenths. 12 tenths take away 4 tenths leaves me with 6 tenths here and 2 tenths here, which is 8 tenths. Put up my decimal. 8 ones take away 6 ones. 1, 2, 3, 4, 5, 6. 8 ones take away 6 ones equals 2 ones. My answer is 2 and 8 tenths. I could write 2 ones, 8 tenths. I could also write this as just tenths. What would it be? That's right, 28 tenths. All right, you guys are doing a great job. What happens if we have to make more than one exchange, or if we have to unbundle more than one number? Now this time, I'm gonna use my place value chart, but I'm gonna write on another piece of paper. Kind of like if you guys were writing in your math book and you were doing the standard algorithm in your math book, but you were using a place value chart just for a chip model. So I'm gonna have 2 pieces of paper here. So we're gonna pretend this is my book and this is my place value chart that I'm working on. And we're gonna do the problem 831 thousandths minus 292 thousandths. And let's say the book is really nice to you. They actually wrote it in vertical form. Actually, I don't know if I have enough room here. I'm going to move it down a little bit. Okay, let's try again. 831 thousandths minus 292 thousandths. Now, super important, I lined up my ones, my tenths, my hundredths, and my thousandths. Even though I'm not using my place value chart, I still have them in a row and columns. And I can also see that my decimals line up when I line up my place values. All right, now down here on my place value chart, I'm going to make my chip model. So first thing I do is look at 831 thousandths. Well, that is 8 tenths, 3 hundredths, 1 thousandths. I'm going to subtract this number. So I need to check to make sure it's possible. 1 take away 2. Is that possible? No, it isn't. I need more thousandths. 1 thousandth take away 2 thousandths. I can't do it. So I need to get some more thousandths from my hundredths column. I'm going to unbundle one of my hundredths. So cross out a hundredth and unbundle it into 10 thousandths. Next step, make sure your standard algorithm matches your chip model. I had 3 hundredths, but now I have 2 hundredths because I unbundled one of them. I had 1 thousandths, but I added 10 thousandths when I unbundled, so I have 10 plus 1, which is 11. 11 take away 2, I can do that. Let's check the next one. 2 take away 9, is that possible? No, it's not possible. I need more hundredths. I can't do 2 hundredths take away 9 hundredths. So where can I get some more hundredths from? That's right, from my tenths. So I'm going to go to my tenths, and I'm going to unbundle 1/10 and exchange it for 10 hundredths. Just like that. Now I need to correct my algorithm to make it match my chip model. I had 8/10, but now, since I unbundled one, I am left with 7/10. I had 2 hundredths, but now that I unbundled these, I have 10 more hundredths. 10 plus 2 is 12. So now I have 12 take away 9. Well, that's possible. I have 7/10 take away 2/10. That's possible. I have 0 ones take away 0 ones. That's possible. So now I can do my subtraction. 11 take away 2. 11 thousandths take away 2 thousandths leaves me with 8 plus 1 is 9. 9 thousandths are left. 12 hundredths take away 9 hundredths. Well, there's a quick 5, 6, 7, 8, 9. I now have 1, 2, 3 hundredths left. 3 hundredths. See how I write it nice and neat under the column to keep it nice and lined up? 7/10 take away 2/10. Leaves me with 5/10. I bring my decimal down. 0 ones take away 0 ones is 0 ones. And that is how you solve a problem when you have to unbundle 2 times. All right, let's try one more problem before you guys do some practice on your own. What if I have the problem 4 83 thousandths minus 1 29 hundredths? First, write this number vertically. I don't want you solving any in your head. You have to show your work. So when I write this number as a vertical problem, I'm going to have 4 83 thousandths minus 1 29 hundredths. Well, I line up my ones place. My decimal will go there. I have 2/10. I have 9 hundredths. Now that looks kind of weird. 3 with a blank space. What would go in that blank space? Exactly, a 0. Next, I make my chip model. 1, 2, 3, 4 ones, 0 tens, 8 hundredths, and 3 thousandths. Now I'm going to check to see if I can subtract. 3 thousandths take away 0 thousandths. That works. 8 hundredths take away 9 hundredths. You're right, we can't do that. We're going to need to unbundle and get some more hundredths. So I look to my tenths column, but there's a 0. There's no tenths. So where can I find some more tenths and then some more hundredths? Exactly, I have to go all the way over to my ones column. So I'm going to start by unbundling a 1. 5, 6, 7, 8, 10. I update my algorithm. I had 4 ones, but now I have 3 ones because I unbundled 1. I had 0 tenths, but now I have 10 tenths. I still need hundredths. I'm going to unbundle a tenth. 1, 2, 3, 4, 5, 6, 7, 8, 10. And I'm going to update my algorithm again. I had 10 tenths, but now I have 9 tenths because I unbundled 1. I had 8 hundredths. I added 10 hundredths to it. So now I have 18 hundredths. Now let's check if this will work. 3 thousandths take away 0 thousandths. I can do that. 18 hundredths take away 9 hundredths. I can do that. 9 tenths take away 2 tenths. That works. 3 ones take away 1 1. That works. So now we can do our subtraction. 3 thousandths, take away 0 thousandths is 3 thousandths. 18 hundredths, take away 9 hundredths. 5, 6, 7, 8, 9. That'll leave me with 8 up here plus 1 is 9 hundredths. 9 tenths, take away 2 tenths. Leaves me with 5, 6, 7. 7 tenths. I bring down my decimal. 3 ones, take away 1 1. Leaves me with 2 ones. And that would be my answer, 2 and 793 thousandths. All right, last problem together. I want you guys to write this down. Then I want you to pause. I want you to solve it. And then I want you to come back and check your answer. And then I'll assign your problem set. Let's see if you can do this one. I think this is one of the trickiest ones I have. 6, take away 48 hundredths. You can use your place value chart to line up your place value. You can use your chip model, do all the things you need to do. Press play when you're ready to see the solution. All right, if you guys are back, that means you've solved this problem. Let's check and see if you got it right. For 6, I would write 6 like this. Then I would line up my subtraction part, which is 48 hundredths. Well, I have 0 ones. I know this is 6 ones, so I have to line up my 0 under my ones place, because I know there's a decimal after that 6. Then I would put in 4, 8. Well, that looks really weird. How can I subtract 8 from a blank space? That's right, you should have put in your zeros. The next thing I would do is use my chip model. I have 6 ones. 1, 2, 3, 4, 5, 6. Everything else is 0. I check my problem. 0 hundredths take away 8 hundredths. I can't do that. I need more hundredths. I look over in my tenths column, but it's a 0. So I have to go all the way over to my ones column to unbundle. I'm going to unbundle a 1 and exchange it for 10 tenths. Let's update our algorithm. I had 6 ones, but now I have 5 ones. I had 0 tenths, but now I have 10 tenths. I still need hundredths. I'm going to unbundle a tenth and exchange it for 10 hundredths. I update my algorithm. I had 10 tenths, but I unbundled one, so now I have 9 tenths. Because I unbundled one, I now have 10 hundredths. Now I should be able to subtract. 10 hundredths take away 8 hundredths. 5, 6, 7, 8 leaves me with 2 hundredths. 9 tenths take away 4 tenths. 1, 2, 3, 4. That leaves me with 5 tenths. I bring down my decimal right in a nice neat line. And I have 5 ones take away 0 ones will leave me with 5 ones. So 6 take away 48 hundredths is 5 and 52 hundredths. This is what we learned today. So now you can go to your blue Learn book, turn to lesson 10, and try the problems. Tonight's homework was the Succeed book, lesson 10. I will post that in the Google assignment as well, so you know where to find your work. Blue Learn book, lesson 10. Then for homework tonight, you're going to do your homework Succeed book, lesson 10. If you get confused or don't know what to do, go back and watch parts of this video to help you. Also, don't be afraid, don't resist. Use your place value chart. It will definitely help you. Use the chip model if you need to. It will definitely help you. All right, work hard, try your best, and I will talk to you soon. Bye-bye.